Today's webinar is on the topic of Wattics for specifically school districts. From a very high-level macro view, our mission as a company is to provide technology-enabled solutions and software to allow you to get value out of your energy information. The design is get your valuable energy and sustainability data into our suite of products and then get value out. And you can better manage your consumption and demand and reduce your carbon and help to drive savings. So that holistically is what the mission of our company is all about. Over the last year, we've been very hard at work creating the next generation of products and tools to allow you to get great actionable information from your valuable data. So many of you are familiar with what we've been supporting and selling for a long time, which is our EnergyCAP platform. EnergyCAP's main focus is utility bill information. So think of it as monthly bill data that has use, demand, and cost values, and a lot of analytics and tools built into that to help you get value out of your utility bills. And specifically for many of our school districts, you've been using the platform to implement energy management projects and behavior-based programs, and then track your before and after. So what your savings are after you've implemented some of these initiatives. But the foundation of all of that has been based on utility bills. We then get to the webinar at hand, which is focused on Wattics. Wattics is our real-time energy and sustainability analytics platform. It's focused on time series data, so interval data. Most commonly would be pulse readings from meters or sensors or devices that allow you to track the real-time behavior and consumption and demand patterns from your consumption and your use going on at the current moment. So that's what we'll be focused on today. We also then have released a product called Carbon Hub. Carbon Hub takes a deep dive into greenhouse gas reporting and carbon reporting activities to help with sustainability initiatives and specific projects focus on reducing your carbon footprint and to do decarbonization activities. So Carbon Hub helps out in those areas. So that's really what the next generation of our EnergyCAP platform is all about. Bill tracking, real-time tracking, and then decarbonization tracking. Okay, specific to this conversation, we're talking about the interval data and the value that interval data brings. Again, many of you already are starting to get a great handle on utility bill information, if not have a good handle on it. So you understand what your usage and demand patterns are month to month and the impacts of cost and maybe the impacts of carbon related to those activities have been on a monthly basis. Interval data brings a whole new element, and this allows you to go deeper and to find better areas for savings and to really expand out what you're doing today and get more granular with your tracking. Interval data and the management of it helps you save money really quickly by spotting either facility, zone issues, or equipment problems. It can be your eyes and ears, and it's working 24/7 to help monitor usage and then alert you to problems. It's really the most effective tool to bring bottom line net positive value for your organization. You know, a utility bill is great, but it's a 30-day snapshot of what your behavior is for your building. And generally, bills are holistically. It's just looking at total building consumption. Interval data lets you go deep dive. It lets you spot equipment issues, so cycling on and off. It helps you identify scheduling problems. We really have looked at this and been engaged with some of our schools for a long time. An example of a scheduling startup problem that I want to share with you today This happened with one of our school districts that was monitoring their schools using e-gauge meters. So every one of their schools has an e-gauge meter on it. So holistically, they're tracking the interval data. Well, if you go back a few years during the COVID shutdown, they scheduled all of their building systems to do deep setbacks for a 2-week period, because that's all the longer they thought they would be out of school and the schools would be shut down. Well, week 3 comes around, and what happens? All of the systems and all the schools start turning on as if they were, functioning normal, and all the students and faculty were back in the schools. Without the interval data, they never would have caught that, and they never would have been able to readjust the schedule to then go back down to a deep setback, and that ended up lasting for the remainder of the school year. Had they not done that, then they would have then, as a result, not seen a huge decrease in their utility bills. It would have been back up to normal. So a good example of tracking using interval data to help with scheduling issues. I'm sure all of you can relate to that kind of issue, because that happened for all of you a few years ago. But then, let's look to present day. We're about to go into the summer months. Do you have scheduling changes, made effectively right now on your equipment? Are your buildings getting ready for the summer months if they're shut down and you really have little to no activities going on in them? Interval data helps to keep an eye on that. It helps to keep an eye on weekend shutdowns. It also not only is looking at scheduling activities, but looking at demand charges. Many, electric rates have demand values to them. And if you go above certain demand values, then you get penalized, and you're paying for it throughout, the remainder of the year. So it helps keep a pulse on even demand spikes within buildings to hopefully mitigate any types of issues that would then later show up on your bills. Helps to identify HVAC or other equipment control problems, or if some of those systems are not operating efficiently. A lot of areas that interval data helps spot problems and draws it to your attention so you can start taking action before it shows up on your utility bill. So a lot of value out of interval data by itself. I very specifically wanted to mention to this group, I know a lot of school districts are using EnergyCAP, M&V, and measurement and verification of savings tools to implement various projects and behavior-based strategies, and then you're tracking the savings due to those initiatives. Well, using utility bill information, you're using generally option C, which is a whole building tracking of savings. One of the issues with that approach is if you are tracking savings, you can't 100% attribute your savings calculations to a project. You have to do some adjustments. You have to make modifications to the calculation, because holistically, from a whole building approach, you can't isolate a very specific piece of equipment or project or time period. The Wattics application lets you go deeper, lets you use option B, which allows you to isolate a piece of equipment or zone in a building, or zone in one of your schools, and then track the 100% savings attributable to whatever the retrofit or project is. So it's a different way to look at savings, but allows you to pinpoint very specific projects and pieces of equipment and get real deeper in your savings calculations. Okay, so let's talk about Wattics very specifically. Hopefully all of you understand the value of tracking interval data holistically, and also some of the methodologies behind the savings calculations. But Wattics is meant to be a real-time energy and sustainability tool that allows you to capture data in real time. You can capture data from different types of data sources. It then monitors the data and can provide alarming and alerting if something's is becoming an outlier or performing as not to be expected, and then helps you optimize savings. There are tools built into finding savings opportunities to run some what if scenarios, but then using option B protocols to then verify the actual savings once you start implementing a project. The whole key to Wattics is acquisition of interval data or time series data. So we built numbers of connections to equipment, to meters, to gateways, to various devices in the field. We can tap into BAS or metering systems. We can get data from utility companies. So let's say you don't have anything installed within your schools and you say, hey, I'm in Texas and I know there's this smart meter Texas thing. How can I get data from my utility company that claims they've installed smart meters on my school? So there's a lot of ways that we can work with you to get data. So if you already have existing sub-meters or BAS systems that are tracking pulse readings, we can connect to those. We can get data from utility companies. We can also recommend hardware. So we resell certain devices. This works really well. So then one-time purchase, you buy meters, you put them in your buildings. You can just clamp on to zones or pieces of equipment within your buildings. You can monitor numerous points within a building. And then the devices we recommend are plug and play ready to communicate right into the database. So you buy, equipment that we can help you, spec and source. You buy it one time, install it, and then configure it to communicate through the internet to the Wattics cloud, and then data is flowing in real time. So very easy solution in the event where you need some type of device to get the interval data. There's a lot of great features within the Wattics application. So not only are we connecting to devices and have a whole library of ways to do that and devices we can connect to, once connected, there's real-time alerting and alarming. There's machine learning to understand patterns and alert you if your usage is falling outside certain expected patterns. There's the ISO 50001 measurement verification of savings compliance. This would be your option C and even option B, which I was talking about earlier, retrofit isolation protocols to help you verify savings. There's heat mapping, so it helps you better understand your consumption patterns and behavior. You can create formulas in the system. Formulas are a great way to track renewable activities. They're great to track targets and projected savings initiatives. A lot of other functions for formula-based calculation. You can track your indoor air quality to make sure that you're providing great quality of air to the students and faculty within your schools. There's tariff analysis and load profiling, dashboarding, which is a big feature to help you communicate the results of things that you're doing and how your schools are performing. And then a whole lot more. And I'll get into all this once I provide a demonstration. But realize there's a lot of great features built into analyzing your interval data. So let's go through a product demonstration. So this is Wattics. Let me start by saying this. If you already have an EnergyCAP subscription, you can add this on. And we have the ability now where when you go to log in, you can log into pick which path you want to go. Do you want to log in EnergyCAP or Wattics? We also have the ability to share objects. So you can share a school and share meters from one application to the next. So, really great way that you can use your existing setup of EnergyCAP and then build on it and sync that data and those objects with Wattics. So when you first log into Wattics, there's some home screens you can come to that are just showing some live values of data for however you want to configure it. It's also showing notifications. Notifications would tell you if there's any types of potential issues or problems with the data as it's coming in real time. So it's helping to flag anomalies in your interval data and alert you of issues. The way Wattics is set up is you have a tree structure to your left, which allows you to set up organization layers, buildings, and then underneath buildings, the commodities that you're monitoring or the points that you're tracking. Of those points, you can have subpoints. So in this case, we have a profile of an HVAC system in this building. Underneath the HVAC, we can also then track all the individual components of HVAC. So your air handler unit, air compressor, boiler, chiller, all of those subcomponents. And each one of these has their own interval profile. The view you're looking at here is 5-minute data. So the system can ingest whatever type of interval your meters or devices are capturing, 5-minute, 15-minute, hourly, just depends what your device is capturing. In the middle, you have views and analytics, and then over to the right, you have filtering of data. So for this HVAC unit, data's coming in real time. This is a profile of yesterday, so just what the interval data looks like for the HVAC in this building yesterday. I can then say, well, maybe I don't want to look at yesterday. Maybe I want to look at the past week. So this is now giving me weekly interval data and allowing me to see on a weekly basis, when is the HVAC generally starting up, where it's peaking out at, and then when it's shutting down to nighttime setbacks and how deep our setback is each evening. So really helpful to look at weekly data, but you can look at it on a monthly, daily, weekly, quarterly basis. A lot of different ways to look at the data. Again, this is the raw data as it's coming in. I can also use it to help with some demand management activities. So in this case, over the last month, let me find the 15-minute highest peak period during a 15-minute window for the week. I could also look at this on a 30-minute basis. Some of that's valuable. If you notice what I just did, the 15-minute peak time period is different than the 30-minute peak. So it helps just to pinpoint potential, areas that you might want to look at as you're starting to do demand management activities. Throughout the application, if you click on this menu screen, you can download images. You can also download the raw data for whatever you're looking at. So you create the chart, and then you can export the data to CSV or Excel. I find this to be very helpful, where if you just want a dumping of various bits of data, you'll see this throughout the application. You can build what you want and then download it very easily and nicely to Excel. Okay, so as this raw data is coming in, there are alarms and that you can configure to alert you of any types of issues. And there's 3 types of alarms. The first type of alarm is a offline notification. What's really valuable about this is it helps you detect if the system has not received readings from a meter over a user-defined period. What you don't want to have happen is, let's say a meter goes offline, or if we're doing file exchanges or API integration, for some reason the automation's not working. Whatever the case may be, you don't want to go too long when you're tracking and monitoring interval data without getting a reading. So this helps you by tracking for every point that you would want to set up a time period that if the system didn't receive a read, it can alert you so you can troubleshoot why the meter would be offline or the data is not flowing. So helpful to pinpoint offline issues. The next is a custom detection that you can set up on any one of your points, where you define what the detection is, what the alarm is. So maybe you want to audit on demand values, and you want to do a demand management activity where if you say, if my demand goes above 300 kW, I want the system to alert me and let me know, so I don't have too large of a spike for demand, so I can limit any type of potential future issue on a bill for demand being very high, any given time during a billing cycle. Or you could say, maybe on a water meter over the weekend, if my usage gets to be incredibly high, let me know, maybe there's a potential leak. So then I can troubleshoot, send someone to the school and take a look at what's going on. So in this case, you can configure what time of day you want to be notified and monitor. You can also decide for what days of the week do you want this alarm to be enabled for. So maybe you have some specific ones that are during the weekends and different ones during the weekdays. Certainly over the summer, you might also have certain alerts to say if your buildings are, starting up and systems are turning on when in July, no one's in the building, no one's in the school, you want to be notified. So you can configure those. You can tell the system to place the notification on a dashboard. I showed that earlier. You can get a text message, you can get an email. So these would be detections that you decide. The last are detections based on a machine learning capability called Sentinel. So these allow you to say, well, you tell me what's reasonable for this specific monitored point, and then you alert me when it goes outside of that. So what the system does is it creates an expected profile, which is in green, and then trends the actual compared to the expected for every point within the system. So every day could be a little different. Every point could be a little different because this is keeping track of, what happens in history, how does weather impact this and seasonality, and then create your expected profile based on, a machine learning process to take all of that into consideration. So for this HVAC point, it's saying, well, generally we have deep setback during, morning hours, and then the system starts to cycle on about 6 in the morning. We have some different time periods where it peaks and then drops off, and then we get some setback at night. You'll notice for this point, what actually we're seeing is, the HVAC generally has been turned on a little bit later in the evening, and maybe more recently, the organization said, well, let's start doing setback a little bit closer to end of workday instead of, a few hours after, and see if we can get some savings. So even though the Sentinel said, hey, generally you're doing this, which is in green, the organization now is starting to take some initiatives to have setback happen earlier in the day, and then they can start tracking the savings of this period here. So the Sentinel is really helpful, where if you go to any point, the profile just is different depending on what's a reasonable trend for that given point. So really helpful machine learning tools built in. Some additional tools. There's a whole analytics tool that lets you look at data a lot of different ways. So sticking with this HVAC example, I might want to say, well, as part of this HVAC, I want to see how my air handler units are performing on a daily basis. In this case, it's May 1st. Maybe I want to say, well, let's see how the air handler unit compares May 1st to May 8th. So in this case, I could say, well, let's overlay May 1st and May 8th and just see what that looks like. Both are the same days of the week, 1 week after the other. And you'll notice, May 8th tended to be more, something was going on in the evenings that didn't happen, the week of the 1st. So it helps where you can compare time periods. The other thing you can do is start to compare points one on top of the other. So this gets to be really helpful when you want to say, well, I understand I have this HVAC operation. How does everything stack, and what's causing the biggest consumption, and what tends to be an outlier? You'll notice this point here for the air compressor, like that was a huge spike. So why did that trigger when that seems to be very much an anomaly compared to everything else? And you can break this up a lot of different ways. So in this case, I could say, well, air compressor is 42% of the total usage for HVAC. And if I had a spike like that, that tends to be a problem. So you can start to monitor and pinpoint exact components to start taking action on. Now, I understand many of you probably don't have metering down to this granular level where you're monitoring all the components of your HVAC systems. That's okay. But hopefully you get the idea that even if you have a master meter or a couple zones within a school metered, then you can start to at least get value for what you do have. So you can overlay points on different schools, one on top of the other. this tool is very effective just to look at your data a lot of different ways. It rolls things up to monthly totals or yearly totals, and allows you to compare all that data. It lets you also overlay weather data. So in this case, I have 2 points, monthly views, and then I can overlay weather data on top of this. Whenever you have the view that you like, you can then save that to a dashboard. So whenever you pick just the kind of view you like, you can save those views, save it to a dashboard, which would look like this. These are many views that I've saved. You can look at the views numerous ways. You know, this is live data today as it's been playing out today, and this gets updated automatically through the dashboard. I can then share this dashboard. So now I have a URL, I can embed this in a website, or just, you know, IM this or email this to other users, and then they can click on it, they get access to the dashboard. This is all outside of the Wattics platform, so they don't have to have a user login. It's a very nice way to share the data with others. Another very valuable tool within the Wattics platform is the ability to look at the data from a heat map standpoint, and then to run some analysis on that data. So let me walk you through this. Let's say I want to look at April 2023 data for the air compressor within this building. So what this is doing here is it's saying, here's what a typical cycle looks like for the air compressor. So I can see in black the higher volume times of usage, in lighter green the less intense periods of usage. So really nice just to see what's going on each month, every day. So do I have setbacks during the times I want? When's the most intense times of usage? You can then run some what if scenarios. So for instance, for all of you, let's say your schools are shut down over the weekends, but maybe the heat map isn't showing you that. What you can do is run what if. Like, what if I could reduce my energy consumption by 80% during these weekend months? I can save this, or weekend time periods. I can save the schedule. It'll recreate a newer heat map, and then tell me what would I potentially save. So in this case, if I could get deeper setbacks on the weekends, I could save 6% for the month. And then there's a rate engine in that shows you what your savings would be. This meter that I'm selecting so happens to be in Europe, so it's showing in euros, but for you, it would show in US dollars. And you can then say, oh, I would save 5% or $565. Great. That's what I would save this month if I could just do some scheduling changes. So it lets you run those kinds of scenarios after you understand your consumption patterns. And then lastly, once you identify some projects to implement, you can run it through the M&V engine and actually calculate savings. So here you can define what a project you want to implement is, what the ECM or energy conservation measure is. You then pick the interval data base period and what the reporting period is. And then it creates a model. So many of you hopefully are familiar with this kind of logic with build data. This is interval data. With this model, it can take into account multiple variables. So it goes beyond what EnergyCAP can do for option C reporting. You can take into account degree days. You can also bring in occupancy or student count, hours of operation. In this case, bringing into account production. It also creates a model for the weekends and then working days or school days. So it's looking at different time periods. So it's a more advanced model. And then what it'll do is calculate the savings. So it'll show you what your base period is, when you did your energy management activity, and then the green being the new actual. So this is the metered actual, and the red being what would have been your pattern based on the model had you not done this ECM. And then down below tells you what your kilowatt savings are, per year and when your payback period is. So, getting up more advanced with M&V calculations using interval data. Okay. That is a demonstration of Wattics, and hopefully you're as excited as I am. I love this app, this tool. It's really going deeper into your building and helping you identify sources of energy, that are energy hogs, those areas that are causing higher spikes in consumption and demand, and then allowing you to better manage it. Just wanted to quickly touch on pricing. So if you're interested, the way that we price Wattics is there's an annual platform fee, and then we charge a per point fee, and the per point fee ranges based on the volume of points and then the complexity. We provide bundled discounts. If you're already licensing EnergyCAP, we can provide a bundled discount. There's also a one-time fee just to help you get configured and connected to your metering sources. If you need hardware, meaning you need meters or any types of devices, we can bundle that as part of the package as well and support that effort. So hopefully that all makes sense. And if you have further questions, please contact us. You can email sales@energycap.com or talk to your sales account manager. I'm also available if you ever want to reach me directly. Feel free to reach out to me.